Hello, we are going to do a little trigonometry in triangles. We have seen regular triangles. These are going to be non-regular triangles. So you will notice in the assignment that I gave today for 9.2 that the triangles that you see are regular equilateral triangles. Now, if you want a challenge, do these scalene triangles where none of the sides are the same measure. You could look at our assignment page for 9.2, questions 14 through 19 have triangles that are non-regular. And so how do we do these? A couple of you attempted this problem during class, so if you want, you can skip forward in the video a little bit. But let's say I want to find the area of this triangle. I'm going to use my normal area formula for a triangle, which says base times height divided by 2 would be how I find area. Because I want to use that, first of all, I can't use the area formula for a regular polygon, that side times apothem dot 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 formula. I can't use that because I don't have a regular triangle. So really my only option here is to do base times height divided by 2. It is nice to have options. In this one, I have to use this one, this option of base times height divided by 2. So my base, I'm going to use the entire length of AC as the base of 16 there. And as you see, I drew in the height that I need right here. So I don't know the height of this triangle that is perpendicular to that base of 16, but I need it. So what I'm going to do, if I need that height, I notice I have my 34-degree angle right here. And that height would be the side opposite my 34-degree angle. Now, what I'm going to do is I'm going to use this side of 10 as the hypotenuse because I get this tiny right triangle right here where I'm looking for the opposite. I know the hypotenuse. If you notice, one of the issues that we would have with using the adjacent here is 16 would be the length of the entire segment AC. So I don't really know what this little piece is on the bottom. It keeps trying to snap that to a triangle that doesn't look, sorry. But I'm going to use the hypotenuse instead, that 10, because I know that one for sure. So opposite hypotenuse, I use a little SOHCAHTOA to figure out if I want to use sine, cosine, or tangent. Sine is the trig ratio that relates opposite and hypotenuse, and that's what I have here. I need to know my opposite side. I have the hypotenuse. So the sine of 34 is equal to my missing height over the hypotenuse of 10. So I can multiply both sides here by 10. Get the height there by itself. If I plug that into my calculator, making sure I'm in degree mode, I would take 10 times the sine of 34. And I got 5.59 for that. That's the rounded version. I'm going to keep the unrounded version in my calculator, try and make it as accurate as possible. But that's it. I have base and I have height. So now I'm going to plug that in to my area formula. 16 times the unrounded 5.59 in my calculator, and then I'm going to divide by 2. And that would give me an area of 44.74, and that would be in inches squared. Okay, so again, we're just doing base times height divided by 2. We have to do a little trig in order to find that height, but that's what we're doing. So if you want to pause the video here and give this one a try, you can do that. And then after you unpause, we'll go through it together. So assuming that you paused that, I'm going to go ahead and draw in my height. My missing height right here creates a right triangle where I know my 48 degrees angle. And this height would be the side opposite. So I'm kind of preemptively doing what we did in the last problem here. I'm looking for my opposite with that height. I know the hypotenuse. But let me backtrack a little bit. Again, I want to use the area formula of base times height divided by 2, where I know the full length of the base here is 21. And I have to do a little trig to find the height. You might notice a little bit of a pattern here. If that height is the opposite side and the side that I know is the hypotenuse, then I'm going to do sine. out of that SOHCAHTOA. I'm going to use sine again. So sine of 48 is equal to my missing height over 12. And I multiply both sides by 12. So again, it's kind of the same calculation here. Same process to find the missing height. And I end up using the exact same trig ratio. When I plug in 12 times the sine of 48 to my calculator, I'm getting about 8.92. Again, that's the rounded version. So I'm keeping the non-rounded in my calculator so I get the most accurate answer possible. So I want to do base times height divided by 2. And if I use my unrounded in the calculator, I'm getting an answer for the area of 93.64, and that would be centimeters squared. So again, if you want to challenge yourself to some of these triangle problems, you could take a look at our 9.2 assignment. You'll see questions number 14 through 19 have triangles like this. You could do a couple of those. I will probably include those in some of our assignments next week. So doing this video and doing those problems will give you quite a bit of a head start on that. So thank you for watching. I hope you have a wonderful day.